In this video, we are going to look at motion in one dimension under a constant acceleration. We organize the main variables used for one-dimensional motion with constant acceleration. Initial time, t0, is considered as 0. That means delta t, which is t final minus t initial, is now equals to just t final, and we simply say this is t. Displacement is delta x, and that is final x position minus initial x position, and we also simplify this as x minus x naught. So initial position is x naught, final position is x, acceleration is a, initial velocity is v naught, and final velocity is v, and the time is t. So using these variables, we will be getting our kinematic equations. Average velocity is displacement divided by time. Displacement is final position minus initial position divided by time. So if we multiply both sides of this equation by t, we get average velocity times t equals x minus x naught, and we can rearrange this so we get x equals x naught plus vt. And the acceleration is a constant. So in that case, the average velocity is equals to v naught plus v, which is the initial and final velocity added together, divided by 2. And also, we have the definition of acceleration, which is change in velocity v minus v naught divided by t. Now, if we use this definition, multiply both sides by t, we get at equals v minus v naught. So from here we get v naught plus at equals v. And also using these equations, we can get this equation for position, which is final position equals initial position plus initial velocity times t plus half acceleration times t square. And we also can get this equation v square equals v naught square plus 2a delta x, or x minus x naught. So this is, we can say delta x because that's the displacement or change in position. We can summarize the kinematic equations as you can see here. All of these equations are only valid when you have constant acceleration. These equations connect position, velocity, acceleration, and time. You do not need to use all of them in every problem. The goal is to choose the equation that contains the variable you want and the variables you know. For example, if the problem gives time, you may use an equation involving time. If the problem does not mention time, look for the equation without t. Among these equations, these three equations are the most useful ones. If you remember these three equations, you can solve any kinematic problem using them. You can use this equation when you are connecting velocity, acceleration, and time. You can use this equation when the position and time is involved. You can use this equation when the time is not given or when you don't have to find the time. The problem solving strategy is list knowns and identify the unknowns. Then choose the equation and then substitute very carefully. Once you do these things, you have to check the units and then finalize your answer. In the next video, we will apply these equations to short kinematic examples.